Hello, my name is Ethan Edwards. I'm a junior and I'm majoring in data science. Today we're going to be going over some particular practice problems in R and just what the commands mean and what the output means and just general information about R. So to start, we're going to go ahead and create a new R script for the first particular problem. And in this first particular problem, we're going to be we're given three items that are assigned a price value, and we compute the subtotal by adding them up, and then the tax by multiplying the that subtotal times the percent tax, and then the total, we assign that to the value of the subtotal plus the tax, and then we're going to be printing an output. Alright, start off, we'll assign value of 5.49 to item 1, item 2, 7.99, item 3, and these are in dollar amounts, so it'd be $5.49, $7.99, and $10. And then we'll create the subtotal variable and assign that to the value of item 1 plus item 2 plus item 3. Part of me that's tempted to add a semicolon after each statement because I've been doing some SAS work, but can't do that. Then here, let's not add a space, and then the tax, it's assigned the value of the subtotal times 6% sales tax, which I actually believe that's the sales tax in Kentucky, if I'm not mistaken. And then the total amount, which is the subtotal, plus the tax. And then this, the cat command, it pretty much stands for concatenate. So what I mean by that is we are combining two things. So in this instance, we're going to combine this string. The total amount due is and then the rounded value of the total, and then the two decimal places, because we want that in a price format. So like, for example, like in this instance, like $7.99 in that format. So to run this, what we do is we go to the end of each line and click run. So as you can see in the console window, it has that value of item 1 assigned to 5.49. If you look up here, it has that value stored. Then we go to the next line, do the same thing, the next line, and as you can see, it's storing those items. So it's stored those first three items right there in the environment window. And then we do the same here. It adds them up, and the total is 2348. And we compute the tax, and it's 1.488. And we're gonna need that. We're gonna need the total rounded because of that. Wait, skip a step. Oops. So we're gonna compute that total, and as you can see, we're going to need to round that up. That's not a price value. So what this does is it combines this string. It prints out the total amount due is whatever the price is. It's stored in that value. I suppose we could just, we could compute that total or round it right here in this line. But this is good because that value could change. That value could change. We could change these items, and that those values could change. So instead of just having the total amount dues and just having the string itself, it's good practice to have the variable and the concatenation statement, because then you won't have to go back and do it like that. But apologize for the rant. But so then we do this line as well. We run this line. So that, as you can see here, it prints out. Nothing happens right here. This is just storing value. There's no variable and a particular value being stored here. So it shows right here in the console window. The total amount due is $24.89. Alright, so that's problem 1. For the next task, we're going to create a new R script. And what we're going to do is we're going to upload this particular Excel file about golf balls. As you can see, I have a lot of stuff from other classes, but we'll just go ahead and do this. I've done this before in a few practice times. So go to golf balls and then import data set. And then we'll keep that name of golf balls. And then import the data set into. Alright, and then we got the data set. Alright, so we're going to focus in on the environment window. And so, didn't clear that out, but pay attention to this. We're going to pay attention to this part. So it says 30 observations. So it's golf balls, which is the name of the data set, and 30 stands for observations. So that just means the particular rows of data. So as you can go down here, there's 30 rows of data. And then 3 variables, which is brand, distance, and durability. And if we expand it right here, we'll see kind of some more details about the particular variables. So like the brand is a character, and then like brand A, brand B, C, it logs those values, or the first few values anyways. And then distance, it's a numerical value, numerical for this one as well, and gives the first few of those. What this dollar sign means is it's pretty much just it's representative of that it's part of this data set. So the best way to demonstrate that is we'll go to this command. You can actually run it as a command. Golf balls golf balls $ durability, and what it'll do is it'll give the all the values of that particular data set. So as you can see, it gives all those values. So what that means, the $ means, is that this durability is a part of golf balls. And when you just put that out, it'll just output the data. A few other commands. The summary command, it's pretty helpful when you just want general information about the data set and about a particular variable. So this we'll look at all the variables in the data set, and it'll give us information about what type of character it is. Like if it's a numerical, it'll give like mean, median, and whatnot. So we'll run that, and as you can see, it shows brand, distance, durability, and different things regarding each variable. Like minimum, maximum, third quartile, first quartile, mean, median, and whatnot. But you can also do that for a particular variable. So sometimes you don't need to know the whole data set, and sometimes that would probably be kind of inconvenient because some data sets have lots of data. But in this case, so we'll look at, for example, the durability, and it'll give us a summary of that. So as you can see, it gives us this little horizontal summary of the different elements of the durability, which can be really helpful. Alright. Next, we're going to we're going to do some expressions regarding subsets of the data. So this is a way to just kind of extract data, not all the data perhaps, but different rows and like for example all the variables but only a few of the observations, and stuff like that. So for this one, so we'll start off golf balls, and then we're going to use brackets, and then one. So this first one I'm going to do, this 1, 4, and then comma. So this represents the first range, which is the observations, and this one's blank. So this means the first 4 observations of, since this is blank, it just prints all the variables out, like all the first 4 observations of all the variables, so all 3 of the variables. So we'll, as you can see, it prints out the golf balls, brand, distance, durability, and then the first 4 observations. The next one, we're going to leave the observations blank, and then do the first two variables. So it's going to have all 30 observations for the first 2 variables. Yep, as we can see, it returns. It shows only 10 right here, but if you look down, it says 20 more rows. So it shows the brand and the distance, which are the first 2 variables in the data set. And then the last one, so we're going to leave this one blank, and then do columns 1 and 3. So this will show all the observations. This one, the C, just represents columns, and it'll show, since it's a comma and not a colon, it will be, it's like saying it'll show columns 1 and 3, not 1, 2, 3. So if we run that, we'll see, yep, it shows the brand, durability, and it shows this 10 and then the 20 more rows. So it prints all 30 observations, since that particular area is blank, the first one, which represents observations. And then the next one, we're going to next problem, we're going to display the standard deviation. And so to do that, what we're going to do is we're going to create a variable result, and then it's SD, standard deviation, and then we're wanting to do that for the golf balls distance. So we use that $, or yes, it's distance. We use that $sign again. So press equal, and as you can see, it stores that result right there. We haven't printed it out in the console, but it stores the result right here in the values. And I apologize, it still shows some of the ones in the prior problem, but it shows that result right there. And then use the cat again. So we type this little message right here that gets printed out. Standard deviation of distance, variable for all 30 rows. In this case, we are doing all 30 rows, because there was no parameters specified. So if we print that out, we'll see standard deviation of distance variable for all 30 rows. It is 9.063967. And if you look up here, it's different from the values. And I suppose, I'm not 100% sure why that is, but I think there's just some pre-programmed into the console that it only goes to a certain decimal distance, opposed to the values. It gives the exact value up here, and it kind of rounds it down here, but for the output. But anyways, the next part, we're going to modify this a little bit so that it shows the first 15 observations. So to do that, what we can do is, so to make it easier, I'll just copy this and then kind of edit it. But we'll do that. Okay, it'll be fine. And I'm not going to do that. I feel like that kind of messes things up. So we'll just type it out again. It's okay. SD, golf. So both lines are going to change. This one is kind of the defining one, but distance. And then bracket. I'm going to do bracket, not curly bracket, but bracket, colon, 115. So we see we have that new result up here, the exact value, and then we're going to kind of change this up a little bit. Alright, so we're going to do standard deviation of distance variable for first 15 rows is, and then do comma result. Alright, and then as you can see, it gives a standard deviation of distance variable for the first 15 rows. And if I'm not mistaken, I believe that is it. Alright, well, thank you very much.